This is one major concept of object-oriented programming, which gives us a lot of security, which was lacking inside the procedural method. The attributes wrapped in the classes are called data members, and the functions that operate on these data are called methods or member functions, that we have already seen that. Since the classes use the concept of data abstraction, they are known as abstracted data types. Abstraction is used for hiding the unwanted information and giving relevant information. Like in this example that we states, like if we are like in a real world scenario of 3 customers going into a bike shop to get a bike. Now the salesman will be there. Each customer will have a different perspective of a bike. A youngster can have, he will be more oriented on the stylish looks of the bike, whereas a mature person will be looking at how much petrol it takes in, how much it will cost and how much the maintenance charges will be, and how much other attributes will be. The other person will be interested in the pricing. He has a particular budget and he has to maintain that. So the salesman doesn't have to reveal all the details to each and every customer. He will only give those customers what they are asking for. They will be given the information that they ask for. And this is what abstraction is all about, giving the relevant information. Encapsulation is combined, encapsulation is combines one or more information into a component. Encapsulation is combining one or more information into a component. Abstraction, it means that the hiding the background details which are not useful to the user. For it, we use normally private or protected access specifiers. Inheritance. Inheritance is the process by which objects of one class acquires the properties of objects of another class. It supports the concept of hierarchical classifications. Each derived class shares common characteristics with the class from which it is derived. Basically, we can. It's basically reuse of code. We have one particular class, and we are having another data type which has more or less the features of the first one. Then we can create a second class which is inherited from the first class, so that we don't have to rewrite all the methods in the second class. So this basically explains the concept. Like we have a bird class which has attributes such as feather and they lay eggs, and we have 2 kinds of birds, which are non-flying birds and the flying birds. These have more or less the attributes and methods of the bird class, but they have extra attributes and they have extra methods. And from each of these subclasses, we can have more subclasses of particular bird types. Inheritance provides the idea of reusability. As I said, we can add additional features to an existing class without modifying it. By deriving new classes from existing one, the new class will have the combined features of both the classes. Abstract class and interfaces. To explore the concept of abstract classes, to understand the interfaces, to understand the importance of both. That is what we will be dealing with next. See, abstract classes is basically like you have. It's basically used as a base class. When you say it's a base class, but you know that particular methods are involved in that class, but you have additional methods which cannot be defined at that point of time. So you write abstract classes with some concrete methods which are defined inside the abstract class, but there are abstract methods which are only declared, and these will be defined only when the classes are extended to particular extended classes. So when we have a abstract method inside a class, we cannot have an instance of this particular class, because there are too many methods which are not defined, and those are relevant for an instance. So we have to refer them only as abstract classes which cannot be instantiated. That is the main thing. And we only have instances of the external classes which have definition of the abstract methods inside them. Methods can also be abstracted. An abstract method is one which is a signature, which a signature has been provided, but no implementation for that method is given. An abstract method is a placeholder. It means that we declare that a method must exist, but here is no meaningful implementation for that method within this class. Any class which contains an abstract method must also be an abstract. Any class which has an incomplete method definition cannot be instantiated. Abstract classes can contain both concrete and abstract methods. If a method can be implemented within an abstract class, and implementation should be provided. Now, interface. An interface is similar to an abstract class within the following exceptions. All methods defined in an interface are abstract. Interfaces can contain no implementation. Interfaces cannot contain instance variables, however they can contain public static final variables, that is constant class variables. When we say an interface, it's basically a set of rules that needs to be maintained inside a class. So when you write a class that implements an interface, it says that these kind of list of abstract methods are there, and these need to be implemented inside these classes. That is the set of rules that an interface says. This is basically done for when we have development environment where